You'll be able to use your formula sheet for quizzes or for tests. That's the formula sheet that was used for the 1 year that they had a EOC chemistry. Huh? I guess there were a lot of people who were physics. All right. So this unit is not too hard. Just really filling in formulas. Most of the formulas have 4 variables, and so you'll know 3 and solve for the last one. So this is the formula sheet that I was talking about. So today we're going to be looking at Boyles. These are the 2 we're going to be looking at today, Boyles and Charles. So Boyles looks at the relationship between pressure and volume, and Charles's looks at the relationship between volume and temperature. This and this are the same. It's just taken out of fractions and put into a linear equation. I don't know why, it just seems to be a little bit easier. Most people don't like dealing with fractions, but those 2 are the same thing. What else? Notice on the other side, let's see. So those are where you have your pressure conversions. That's what you'll be using tomorrow. And sometimes you have to use here. Also, if you want to go from Celsius to Kelvin and you forget for some reason, that's always there. You just take your Celsius and add your 273. Even though we're adding or subtracting 273, it's really 273 with a bunch of zeros behind it. So that's why it does not affect sig figs. These are considered like a conversion factor, so that's not going to affect your sig figs on that. All right. Let's look at our notes. All right. So first one is Boyle's law, and looking at pressure and volume. The temperature is held constant. If something's held constant, that means it's just not part of the formula. If the temperatures are constant, it would be the same on both sides. So you would cancel it out. So at constant temperature, the pressure and volume are indirectly related, which means if I increase the pressure, it's going to decrease the volume. They're going to do opposite things. And that's if I increase the pressure, then that's going to force the gas particles closer. And because of that, the volume would decrease. So this is going to be your graph that would represent that. On my y-axis, I have volume, and on my x-axis, I have pressure and atmosphere. So you have a negative slope because as my pressure increases, my volume is actually decreasing. So that's why you end up with a negative slope. So my formula for this is P1 V1 is equal to P2 V2. The units must be consistent. So for instance, that means if one pressure is in atmosphere, then your other pressure has to be in atmosphere. Or if one volume is in milliliters, your other volume has to be in milliliters. So it doesn't have to be in a certain unit in this formula, but they just do have to be consistent. So they would be able to cancel out on each side. All right, so we'll just look at a couple of problems like that. Like I said, you can see you have 4 variables. We're going to know 3 of them, and you're going to do a little algebra to solve for the other one. So if we look at our problem, a balloon is filled with 25 liters at 1 atmosphere pressure. So liters is a volume. So this is my V1 and my P1. if the pressure changes to 1.5 atmosphere, so that's my P2, what is the new volume? So V2 is my unknown. So my pressure is going from 1 atmosphere and it's increasing to 1.5 atmospheres. So when I solve, should my V2, should it be larger or smaller than 25 liters? Yeah, it should be smaller, right? Because I'm increasing my pressure. And that's just a little quick check you could do to make sure you didn't set anything up incorrectly. All right, we're going to use my formula here. So now I have everything. I'm just going to start filling it in. P1 is 1 atmosphere. V1 was my 25 liters, is going to be equal to, let me get this out of the way, is going to be equal to my pressure 2, which was 1.5 ATMs, times my volume 2, which is my X or my unknown. Both of my pressures are in atmosphere, so that's consistent. My volume is in liters, so that means when I solve for my other volume, it's also going to be in liters. So what do I need to do to solve for this? What's my last step? Divide by 1.5. So that's the little bit of algebra you have to do. This cancels out, and this is what goes in your sig figs. I'm sorry, goes in your calculator. How many sig figs would you have? 2. I think everything on that one has 2. So try that out, put it in your calculator, see what you get. Yeah, so 16 point something, but you have to have, yeah, perfect, 17 liters. So most people usually find this easier than stoichiometry, especially since you don't have to memorize a bunch of formulas. So if you were not happy with your last 6 weeks grade, which is probably our hardest 6 weeks, and this is your opportunity to have a good 6 weeks grade. All right, let's look at one more of those and then we will move on to the other one. A balloon is filled with 73 liters of air at 1.3 atmospheres of pressure. So 73 liters would be my V1, and that's my P1. What pressure is needed to change the volume to 43 liters? So there's my V2, and my P2 this time is my unknown. My volume went from 73 liters to 43 liters. So should my pressure be more or less than that 1.3 atmosphere? More. So once again, I just kind of look at that. So I don't, in case I accidentally make a mistake in my calculator, it's pretty easy to catch. All right, we're just going to start plugging in. My P1 is 1.3 ATMs times my V1, my beginning volume, 73 liters. My P2 is what I'm trying to find, and my V2 is, what was my V2? 43 liters. Both of my volumes are in liters, so that's consistent. Since my given pressures in the atmosphere, my P2 will end up being in atmospheres. How many sig figs on this one? Also happens to be 2. So when you put that in your calculator, 2.2, that's what I think I heard over there, 2.2 ATMs, 2.2 atmospheres. All right, so that is Boyle's law. And then we'll look at Charles's. So Charles's law is whenever we're looking at volume and temperature. So on this one, the volume of a gas is directly proportional. Really, Boyles is the only one that you have indirectly. Pretty much everything else that we look at are direct relationships. And the temperature has to be in Kelvin. You know, on your practice, we didn't really deal with Fahrenheit or talk about it in the notes because those really aren't the two. We tend to either be given in Kelvin or have to move between Celsius and Kelvin. Don't do really Fahrenheit in chemistry that much. And that means if the pressure is held constant. So all that means is if I increase my temperature, it's also going to increase my volume. You can think of it as temperature is like putting more energy into the system so the particles would spread out more and the volume would increase. Don't forget, if you're giving your temperature in degrees Celsius, you simply add 273 to it. And that'll get you changed over to Kelvin. However many places behind the decimal you're given Celsius is, that's how many places behind the decimal you should have your answer for. And this is a direct relationship, so that's why we have a positive slope. As one increasing, the other one is increasing too. So this one is V1T2 is equal to V2T1. Notice that the volume and the temperature, they're opposite. So in other words, if I have V1, it goes with T2. That's because of the direct relationship. And then the temperature has to be in Kelvin. Kelvin is the only one that doesn't have any negative temperatures. And so since we're looking at changes here, that's why we need to be in Kelvin. All right, so let's look at a couple of these. What is the temperature of a gas that is expanded from 25 liters at 2.5 liters at 25 degrees Celsius? So that's what I started at with. That's my V1, that's my T1. And it's expanded from 2.5 to 4.1. So that's my V2. And I'm trying to find my T2. Once again, if it says constant pressure, that means it's not part of the formula. Constant, it would be canceled on each side. So we're going to use our formula here, start filling in. So my first volume, what I started at was 2.5 liters. My T2 is my unknown. My V2 was my 4.1 liters, and my T1 was my 25 degrees Celsius, but I need to get that in Kelvin. So I'm going to add 273 to it. And that gives me 298 K. So that's what I need to put in as my T1. All right, a little bit of algebra. I'm going to divide each side by what? 2.5, 2.5 here, 2.5 here. That cancels out. Since my first volume, what are we trying to find here? Temperature, never mind. Since my temperature is in Kelvin, that's going to be my answer is going to also be in Kelvin. How many sig figs? 2, perfect, all right. So what do we get whenever we adjust for sig? 490 K. Anybody have any questions on that one? Yes, sir. You get it from whichever one is less. So these are all your measurements that you're given. They all happen to be 2. So that's why you had 2. But look what you're given, and whichever one has the least number of sig figs. That's going to be like the next one. I have this one is 2. That one is 2. This one is 3, but I need to go with the smaller. So that whenever I get my answer, it'll only be 2 sig figs. All righty, we'll look at one more of these and then y'all can give it a couple of try. So it says, what is the final volume of a gas? So right there, it tells me my V2 is my unknown. That starts at 8.3 liters. So there's my V1 and 290 K T1 and is heated to 369. So that's my T2. My temperature went up. My temperatures are already in Kelvin, so that makes it even less work. So I'm just going to start filling in. V1 was my 8.3 liters. T2 was my 369 K. That's equal to V2, which is my unknown, my X times my original temperature, which is 290 K. All right, so there's my setup. So divide each side by 290. And since my volume that was given in liters, then my answer will also be in liters with 2 sig figs. All right, what do we end up getting? 11 liters. I think you got something like 10.56 or something like that. Then 2 sig figs would be 11. Not too bad. It gets kind of repetitive, like for several days.
Wait, does it matter what order?
No. Yeah, just think of it like if you do 2 times 3 is 6 or 3 times 2. What does matter, like this is probably on this formula right here, this is probably the most common mistake I see. Notice how T2 is with V1, and some people just start, doing it real fast and they tend to switch the temperatures. So
That's what I did. I was like,
yeah, that's probably the most common one that I see. It's just switching the T1 and the T2. But as far as this part goes, that doesn't matter. I could say T2 times V1 and that would be okay. Don't scare me.
Well, but, her pass, her red pass was in the stuff that the book.
Oh, let's see. I'm bad. Nope, I just had mine. Tell her I'll go down during, well, whenever I have my conference, and if it's there, I'll put it back in orange. All righty. So let's look at a couple of each one. So this one says it's Boyles and Charles, on the quiz, it's not going to say Boyle's law or Charles, you'll have to know which one to use, but it's not too bad if you have, because you'll have your formulas right there. All right, so why don't you we'll do this one right here. Y'all know it's Boyle's law. So that one is P1V1 is equal to P2V2. So see if you can work that out, and that one is the correct answer right there. All right, were we able to get 0.859? All right. So 3 sig figs, I think we had a couple of things that were 3 sig figs. So that's why our answer would be 3 sig figs. Any questions on that one? You good? All right. All right, we'll look at one more with Charles's law down here. And this is actually should be 510. That's the answer to 237. Oops. 237. 37 degrees Celsius. All right, so this one, it says a balloon occupies 2 liters at negative 45.5 degrees Celsius. So that's my V1 and my T1. What would the temperature be in Celsius? So that means T2 is my unknown. If the balloon occupies 4.5 liters. So that's my V2. So my final answer when I did it, it needs to be in Celsius. It seems like I should be able to plug that temperature, leave it at Celsius, plug it into the formula and get my answer, but you will not get the right answer. Even if you want your final answer to be in Celsius, you still have to put it in Kelvin to go into the formula. So I'm going to take my negative 45.5 and add 273. And that's going to give me 227.5 K. So that's going to be my T1 after I convert it. Like I said, how many places behind the decimal is going to be because of your given? That had 1 place behind the decimal, so my answer would have 1 place behind the decimal. All right, and then after that, you're just ready to fill in. So I'll give y'all a minute, see if y'all can come up with that. So this is what you should get for Kelvin after you adjust for sig figs, and then whenever you, instead of adding, what are you going to do with your 273? Subtract, yeah, just subtract it, and that'll take you from Kelvin to Celsius. Yes, sir. What? Okay, yes, sir. Want to bring it up here? What you got? No, because our formula is V1T2 is equal to V2T1. So your T2, that's going to go there, which happens to be my RX. So that should go right there. Mhm. Yeah, look on your, I have mine right here. Just remember that's kind of a common mistake, but it's because of the relationship, the T2 goes with the V1. Okay. Okay, let's see if I. You get. All right, let's see. Let's go over our numbers because oh, my head hurts. Well, when it was in Kelvin, what did you get? 510. Okay, but with no decimal, right? It's just 2 sig fig. And this is 227.5. You have all those same numbers right there. Okay, so 4.5 times 227.5. divided by 2. So at this point, I got, I got this. What you got? But it can only have 2 sig figs because this is only 2 sig figs in this. So this would become 510. Okay. And then when I do 510 minus 273, I get 237. What are you getting right there? Did you find it? All right. Any questions on that? Okay. So y'all have a little bit of time. Your practice today is Boyles and Charles's law. And or you can go back to your stuff you're going to be quizzed over tomorrow if you still don't need to worry about those. And anyway, that's what you can do for the rest of the time. Move on tomorrow. Some more laws. If you have questions, let me know. Probably aren't the only one.